right, well, thank you all for coming, and thank you all for staying for OGC. This is everything you need to know about OGC layers and ArcGIS API for edX for JavaScript. And same as before, this is going to be on GitHub. So the presentation, all the demos that you see, if you didn't get a chance before, feel free to take a snapshot now. The link will also be in the proceedings, so you can have it then. So we'll just give you a minute to capture that information. Or move on up to the front, get a better view. All right, excellent. Okay, so again, I'm Noah, this is Jan. We're going to dive into OGC. So we're going to start off with what's supported. This presentation is specifically about 4.x, but we're going to talk about two things from 3.x because they're still worth sharing, and we do have support for it in the API. We support WMS, WMTS, and then for 3.x, it's WFS, WCS. And then we have full support for KML, and then we'll talk about the I3S spec, and then we'll talk about scene layer, integrated mesh layer. And we have, if you're new to OGC or you're new to Esri's OGC, we have documentation about it that you can find. If you just Google like Esri OGC, you'll come to this page and it'll talk about how we apply our best practices to it and what it means for working with Esri using OGC data. All right, so the big thing to note about OGC is that you occasionally run into CORS problems. When you're talking about having services on a different domain, perhaps it's a domain you control, perhaps it's one that's controlled by the government. If they're CORS enabled, all you have to do is push that server to the Esri config and you'll have no problem consuming those resources. If it's not, you're going to want to use the Esri resource proxy, and then you can simply add that URL in the proxy rules, and then you'll be able to consume services from there. And we have information in our guide topics in the SDK about how to do exactly that. So let's look at a real example from WMS, the web map service. So here I have soon to be a beautiful web map service coming from France. This is going to show hydrology studies and observation stations there. So we have the different regions that are being observed and then the actual tributaries of the water. And if I open up the developer tools, it's a very simple application. The first thing we do is we actually push the server to our Esri config. So this is the server where the data is coming from. And this is our Esri config statement. Then we have the URL of the actual WMS. We save that as a variable. So when we create our WMS layer, all we have to do is instantiate it here, pass the URL in the constructor, and then the way we'll add to the map is in the map constructor, we'll actually add layer as a value for the layers property. And that's all it takes to display WMS as long as we've added it to our Esri config. So, and this is the code snippet that I just showed you earlier. What's fun to do is you can actually add simple things like the legend list and the layer list widgets that we've already been using with map image layer, with feature layers. You could easily add those to your WMS layer as well. And here the layer's not quite loading. So in the lower left, we have the legend widget, and this is pulling it directly from the service. In the upper right, we have our layer list widget. If you haven't seen this, it's pretty cool. They've had it on Web App Builder. You can turn layers on and off, and you'll see it updated both on the map and also over here in the legend. There's a little lag time because it's a WMS service that is probably getting a lot of traffic right now. So that's our legend and layer list widget. And to see what the code looks like, it's the exact same code as if you're working with any layer from Esri. And that's you create a variable called layer list, you apply the view to it, and if you were here earlier, you saw you could have multiple views for the same map, and then you add it to the view.ui, and we said we're going to place the layer list in the top right. Same principle for the legend, you create the legend widget, assign the view, and then place it in the lower left. So then now you have an even more full-featured web application.
So yeah, the WMS is the equivalent in would be for us would be the map image layer and map services. So the way it works, like every time you finish panning or finish zooming, we issue a request to the service to ask for an image for the current view extent, and we pass some parameters, like for example, what are the different layers of that service you want to display. So yeah. To scroll down, all at the bottom. Yeah, so we pass the width and height of the image, so which will be the width and height of our view, and then the bounded box, the envelope we want to display, and then some other parameters and the layers at the bottom that we want to show. So every time also in the layer list you make one of the sublayer not visible, then we will reissue another call to get another version of the image.
All right, so also similar to the map image layers, you have sublayers with the WMS. And the great thing about having access to sublayers is that you get a lot more control over how that data is visualized in your application. So here we have, again, the same web app, but we've actually accessed the sublayers. And if you notice in the top right, the layer list widget is looking a little different. It's no longer in French. We translated it, and now you can actually see it in English.
I was fine with French.
Yann was okay with French. Some of us, you know, your mileage may vary, but si tu peux parler français, ce n'est pas un problème. But if we look at the developer tools, we can see what the code looks like there. So again, if you're used to map image layer, this is going to be the exact same concept. So I'm going to come down. We're doing the same thing. We're adding the server to the Esri config. We have our URL, and then we have in our sublayers. I'm going to give it, because I looked at the network traffic that Jan pointed out earlier, and I saw that these are the 3 layers that I'm really interested in. And if I translate what their titles were, when I apply to a layer list, I can actually customize the text, and show that. And then I have my visibility. And there's other options as well if you want to play around with the visualization or the styling of the layers. You have access to all of that.
So those automatically, the title that you specify on the sublayer, they translate. They are used by the layers list to display, and also the legend.
Yeah. And if you didn't know how to find that in the network traffic, or you've given a service that you want to play around with it, this is what the typical get capabilities request returns to you in an XML format. So here you have all the information about the title of the layers and the spatial references and what's supported and what's not supported. And that's what we were pulling out when we decided how to style the sublayers. So with that, I'm going to turn it over to Jan. He's going to dive into WMTS.
Yeah. So the problem of WMS is that every time we pan or zoom, we issue a new request with the exact dimension of our view. So this is not cacheable, for example, in the web browser. So there is another specification called WMTS for web map tile services. So it's specialized to display the data in a tile fashion. So here we have like a tile service, and then we can see that if we go into the developer tools, the network tab, as I pan around, we ask for more images, and it's not just really when I stop that we request for one image. So we request for fixed size images. So in this case, they are like, I guess, 512 by 512 or something. And the advantage is that when I reload my app, the image is already in the cache, so it's not really re-downloaded from the server. All right. So this is how you create a WMTS. Same restrictions. Either you specify a proxy on your app so that we can ask for those data. But if you know that if you know that the service supports CORS, you can add it to the CORS enabled server. So like that, you don't have any issues fetching the images. And then you specify the WMTS URL endpoint. And you specify which active layer you want to show. So it's an equivalent of our tile layer, but the WMTS has some extra capabilities, like for example, having multiple cache in different spatial reference of the same layer of data, or having multiple layers compared to our map services, which is like one cache for one configuration of the data. So the WMTS is like a catalog of multiple tile layers. So we specify which layer we want to display in that service. So that same service I just showed you, we have a sample in the SDK that goes through all the different layers that are in that service, and then we expose a big list of all the different layers. So then after we can choose the one that we want to display. Whoop. So sometimes they are just like, you have to be, Blue Marble, for example, is nice, from NASA. And this is how it works in the application. So when the layer is loaded, we have access to all the different sublayers of that layer. And then for each one of them, we add an option in that drop-down on the top of the app. And then when we change, when we select something in that drop-down, we change the active layer by looking at the one that was selected by the user. Automatically, we refresh, we redraw everything. Okay, so something not yet supported in Forex, we haven't started the development of in the Forex version of the WFS. So WFS, Web Feature Services, it's the equivalent of our feature service. So I will show you the 3x example. So to create a WFS, so this is only available yet in the 3x API. You create a new WFS and then you can pass the different options. So the URL and then the version of the WFS that you are using, as well as in which projection you want to display your features. And so this is how it looks. They are real features downloaded to the client. The big problem of WFS, there is a new specification that is in the work, is that the transportation format is XML, and it can be very quickly expensive in terms of size and parsing on the client. But yeah, it's an equivalent of our feature service. Okay. Next, we have WCS, Web Coverage Service. So it's the equivalent in Esri, at Esri of the imagery layer. What is really nice about this layer is that it brings the data in a format that we can parse and render ourselves on the client. So all the pixels of this image are actually colorized by JavaScript code. And the advantage also is that we can do very interactive visualization here. Like I can, when I move my mouse, I can actually know what type of land I'm hovering over. So in this case, I'm over grassland, and in this case, I'm over cropland. I can as well filter on to see only a type of pixels that I'm interested in. So all the grasslands all over the place. Right. So equivalent of the imagery layer, you can define a WCS with a WCS layer with a WCS URL, and then you specify the version of the specification that you are using, as well as the pixel filter. So that colorizer function, I won't show it, but it will basically colorize the pixels based on the type of land that it is. So in green in the case of grassland. Okay, finally, my favorite by far is KML. So KML is an OGC specification. It's that specify in XML a complete map. So you can, we use that as a layer. We consume it as a layer, but in this case, we have like different features with different symbols, and it has also a custom pop-up. So we honor that in 4x as in 3x. And if we go same layer, we specify just the URL to a KML. We try to support as much as we can. We won't support the entire spec because this specification was made around Google Maps, Google Earth in mind with the Google Earth UI. So some of the aspects of the specification, like screen overlays, won't be supported because they really don't look good once not displayed in Google Earth. But yeah, it's simple. We just point to the KML and then add it to the map. If we look, finally, we have support also for ground overlays. So if you specify a KML layer that points to, that has ground overlay, so this is one of the objects that you can have into an XML. Ground overlay is an image that is georeferenced. So it has like the coordinates of, like the extent of the image, then we can display it on the map. And then finally, a new one, which is the index 3D layers. So scene layers. So it's the OGC specification that is powering all the 3D layers of Esri. So it's an OGC spec since recently, and you can go. There is a GitHub account with lots of details. So the OGC website and this website gives you a lot of details about how the format, how like an OGC package is organized and so on. So we can display like scene layers of points. So in this case, it's like a cache. So a scene layer is basically a cache like tile layers, but for 3D data. And in this case, we have like points. As I zoom in, we will see more points appearing in some areas. Yep. So that's one of the options. The other option is integrated mesh. So this was demoed at the plenary. If we didn't have this, you can see that the integrated mesh arriving. It's basically combinations of elevation and also the features of the 3D features, like in this case the different trees as well as the half dome in Yosemite National Park. If we wait long enough, they will display. Yep. Scene layer. Oh man, I forgot to show that. So in the first example with that point layer, we can define the renderer the same as on a feature layer. We can display points 3D, like in this case, a points 3D symbol, and then different variables. So we vary the size of each of our little spheres. And then integrated mesh. So this is the tiles and the Yosemite National Park sample. And so all I had to do was to create a new integrated mesh layer with the URL that points to the data, and then add it to the map. We are not the expert in the 3D space, so if you want to know more about them, there are plenty of sessions about. Do you want to talk about those? Do you know? And we have also our colleagues from Zurich here this week on the island. So, and we will take questions. If you have some. Yep. No, it supports KMZ too. Yeah. So the way it works, the way we don't interpret client-side the KML, we ask a service on ArcGIS Online to translate the KML to something we can process and display. So we just send it the URL to the KMZ, and then it uncompress there, and then send us back the features. I am not familiar with the number of features. I have never tested a KML with a lot of. I haven't seen like a KML with a lot of features, but if you have, like everything I've been testing, it seems to be working. Yeah. Yes. So the question is there a benefit on using SubLayers for performance? No, not really. It's in the end, we ask all the time the same service. It's just configuration. So the SubLayers are just like a description of what is inside that service, and then you can just change their visibility. Or then after, it's on the server implementation. Like if you have like 100 SubLayers, and then the server has to query for all that data in the database, there will be it might take more time for sure. Yeah, but on the client, it's images that we display, so there is no the same. No, yeah, the problem of a WMS and map image layer is that as you pan, like most likely you will go to a different extent every time, and then the size of the view is always different, so it's not cached in the browser, and I don't think it's cached also server side. Whereas WMTS, it's a cache of tiles, so it's cached on the server side, and it's going to be cached also on the client. Yeah. Any other? I don't have an idea right now. It's I think WFS and I had a lot of people asking for WFS since yesterday, so I will bring that up after Dev Summit, but yeah. I can't say any date. So the problem of so the question is about if we can get the capabilities without cores, without proxy. Yes, if the service supports cores and you add it to the list of supported server, we won't use the proxy for WMS. The problem we have with WMS is that sometimes the get capabilities is cores enabled, and then the URL for getting the image is not. So, like the server that was used there from GeoBretagne is like does the right thing. So it's very cool to work with it, but sometimes we don't know. Any other question? Yeah.
Our customers use those OGC services a lot in our applications. Sometimes, publishers make mistakes and something else happens, and our software is not working properly with some kind of this. There is an ArcGIS online map viewer where you can add a layer from web. And that was okay, but they supported both HTTP and HTTPS. But now it always forces to HTTPS, and when I try to check some VPS that doesn't support HTTPS, it fails. So it would be good to have dual protocols so you can go for this ArcGIS and
Yes. So the question is about like the HTTP and HTTPS support. Yeah, I think like there was work recently about like enforcing HTTPS. I don't have so much details about it, but we can ask back on the island, I guess. But yeah.
Cool. All right. If there's no more questions, thank you all for your time.
Yeah. Thank you.